So our strategy on these. We're going to be mixing two different things together. So it might be, like I was looking at some food science questions for their contest and helping with those. And so it would say they're making a mixture of cream and they have some cream that's 30% fat and they have to mix it with milk that's 2% fat to get 5% fat in the final mixture. You know, how much of each do they need? Those kinds of things. And so what we're going to do with that is we're going to have to take the amount. Okay, if I am so my kids, they like apple juice, but I won't let them drink just plain apple juice because I think it's got too much sugar in it, so I always water it down. Yes, I'm one of those parents.
My parents do the same.
Actually, I won't even buy apple juice anymore, but when when I'm nice and buy it, I water it down. So if I'm going to make them apple juice, I have to know how much juice am I starting with. You know, are they getting an 8-ounce cup or what? And then we have to take it times the concentration. Okay, if I'm watering and I'm diluting that so they're only getting 50% apple juice, so it's half water and half apple juice. Okay, so if I were going to give them 2 cups to drink and it was 50% apple juice, how much actual apple juice is in that cup? 1 cup. If I start with 2 cups and 50% of it is apple juice, then half of it is apple juice, so that's 1 cup. So if you take the amount that they're given times the concentration, you get the amount pure. The amount of pure apple juice. So if we're going to be extra nice, it's Christmas, I'm going to let them have 75% apple juice. Okay, so
yes, sir.
I know, I'm just the nicest parent ever. So we're going to give them 2 cups and it's 75% apple juice. How much actual apple juice?
Half of one of the cups.
75%.
Still wrong.
3/4.
What was the question again?
If I'm giving them 2 cups to drink,
Okay.
A cup and a
What do
half.
you mean still wrong? If you have 2
and
cups, then give them
it's
half of one.
75%
That would be half.
Cup and a half.
apple
No,
juice.
you have 2 cups. Half of one of the cups has water. That would be
No, you're wrong, Carson.
3/4 of apple juice.
No.
No.
It's 1.5.
20 starts. 1.5.
1.5.
It's 2 cups.
How about Noah gets apple juice?
Carson doesn't get any apple.
You're answering how much water is in it.
Oh.
And I want to know how much apple juice is in it.
Oh, I thought you were. Okay.
So-
We love Carson.
Yes.
We love Carson.
He knew what he was saying. He was just answering the opposite of what I was asking.
We love Carson.
He was doing it intentionally. What do you mean?
Okay, so here's our first question. So you're in chemistry class. You have a pure alcohol that has to be added to 20 liters of a 40% alcohol to increase the concentration to a 50% alcohol.
Sure.
Okay, there's a lot of information here because I'm talking about a pure, a 40%, a 50%, I've got 20 liters of this, I don't know how many liters of that. It is hard to keep all this straight.
This is OSHA approved.
So what we are going to do when we have problems with a lot of different things like this, we are going to make a table to organize our information. Okay? So,
Wait, a table?
we are
Gosh,
making
dang it.
a table.
Could we just make it into a ratio? No.
A ratio.
Wrong.
How so?
Like 20 liters of 40%. Divide 20 by 5 would be 10%.
It won't necessarily work like that.
That is right.
Because the amount, your final mixture won't have 20 liters in it anymore, so it won't be 10% in the final. So, what we're going to put here, these are your labels. We're going to label our rows. You can be as specific as you want on these. It needs to make sense. When I'm looking at this, your table is going to be how you're identifying your variables. So don't be one of those people that just makes a table and doesn't label anything. Then you're not going to get your points for labeling your variables. You can call these, you know, the first, the second, and the total if you want. That's probably the most generic. If you like to be more precise, what things am I mixing together?
Alcohol.
Pure alcohol.
Pure alcohol and
Concentration.
What?
I'm taking
40%.
and I'm mixing it with the 40% to get
50%.
50%. So I don't care. You can label it first, second, total. You can label pure, the 40%, the 50%. It doesn't matter. Then across the top, my columns are going to be that formula we said. So we said amount times concentration equals the amount pure. All right, those labels I want to see when you do this. Don't just make me a table with random numbers. Label what it is. Now, if we can fill out this table, then our equation will really kind of write itself. So if I start out, how much pure alcohol? So the amount of my pure, I don't know it. That would be my X.
Oh.
So my next question, if it's the concentration, if it's pure, what is your concentration?
100%.
100%. When you use percents in a problem, you always change them to decimal form.
1-0.
So 100% is just 1 or 1.0.
Dang, got me.
All right. Should be added to 20 liters of 40%. So where do I put the 20?
Amount.
The amount of the second one.
0.02. Right?
No,
No,
it's
Point
20
oh-
liters.
0.2.
That's 20 liters.
No way.
Yeah, why didn't you label liters?
So the 20 liters, the concentration is 40%,
Literally.
so that's 0.4. Okay. To increase the concentration to 50%, so where am I going to put that?
Concentration.
The concentration of my total is 0.5. All right, so a couple things here. Sometimes on these problems, people get confused on which two am I mixing and which one's my total. So you always have to mix your highest and lowest concentration together, and your total will be something in between those two numbers. So if I had set this up and I had 1.5, 0.4, is it possible to mix something that's 100% and 50% to get 40?
No.
No. So do a quick check there. Your total concentration should fall in between the other two numbers. All right. We have some gaps in our table, so we need to figure that out. I don't know the amount of my total, so let's think about it for a second. If I put in 5 liters of the first one, and then 20 liters of the second one,
X plus 20.
we add them together to get the total. So this would be X plus 20. Right. We've actually done the hard part now.
Will you just multiply like building?
My formula says amount times concentration equals this. So we just multiply. X times 1 is X. 0.4 times 20. You could go ahead and multiply that. I'm just writing it out for the purpose of your notes so you can see what we're doing.
8.
And then we'll do 0.5 times the X plus 20. And yes, if you want to go ahead and multiply it, that's fine. Okay, so here's what's going on. I have figured out in the first thing I put in how much pure alcohol I added. And this is the amount of pure in the second one, and the amount of pure in the total. So what should I do for my equation? Add them. Add the two you put together to equal your total. So when you get to this point,
Yeah, I definitely did not get that.
we're just using those, and we'll add the two we mixed to equal the total. So it'll be X plus my 0.4 times 20 equals my 0.5 times X plus 20. Okay, 0.4 times 20
8.
equals 0.5 x, 0.5 times 20.
10.
So I can subtract over my 0.5x, subtract my 8. Divide by 0.5. So 20 divided by 0.5.
That's a 2 divided
The
by
2, yeah, it should be 1.
It's still 4, but.
Yeah, I said 20, didn't I?
Yeah.
I meant 2. I wrote 2.
You did it all the way right. Except
Yeah,
for-
yeah, I don't know what I was saying, but.
Growing
Alright. So then, am I done?
You got it right as well.
Okay, the question was how much pure alcohol? When I look at this, my X was the amount of pure, so that's what I needed. So,
The amount of
4
pure
liters.
alcohol
4
is 4
liters.
liters.
4 liters.
Mhm.
Wow.
Killing us there.
Do we have to put units in the chart?
not in the chart, but in your final answer.
You said
I thought you said put it in the chart.
No, as long as you've got the labels
On the side.
on the columns and rows, you're good there.
Um,
Alright,
You guys ready for some more spaghetti?
is that one okay?
Yes.
Gage?
You said
Yeah.
you wanted it. Dude, what?
Yeah.
That's my hand. You got a pearl. If he ain't gonna catch it, that's my hand. That's the pearl.
Chill.
Alright, I want you guys to take a minute and see if you can set this one up. You can label your rows first, second, and total if you want. You can be more specific, it does not matter. But let's go through the question. If I just looked at this without even reading it, and I looked at my concentrations, which one has to be the total?
15.
15. You have to mix the high and low to get something in the middle. So we know that. Alright, the first question. How many liters of a 25% solution? So I don't know it, so my amount is
X.
concentration.
20.25.
Okay.
Point.
Should be added to 5 liters of a 10%. So my second one, my amount is concentration,
Freak.
Yeah, that's what I thought.
0.1 or 0.10, to obtain a 15%. So my total has to be 0.15. Alright, so if I put in X of the first and 5 of the second, X plus 5. How do we get this last column?
Multiply.
Multiply, follow the formula we wrote at the top. So this would be X times 0.25, so 0.25X. 0.1 times 5 and 0.15 times the X plus 5. And then what do we have to do for the equation?
Some equal to each other.
Add the first two, add the two you mixed to equal your total. So we get 25x plus 0.5 equals 0.15x plus 0.75. Subtract over the 0.15x.
Oh man.
Subtract the 0.5. Divide by 0.1 and you get 2.5. So then write a sentence to answer the question. And we want to know how many liters of the 25%. If I look, that's what X represented. So there must be 2.5 liters of the 25% solution.
I don't think it's good.
I apologize. I said to fly your
The surge's been happening.
kept landing on my biscuit.
Oh,
He wouldn't leave me alone. He haunted my dreams. Took my family.
All right, let's try. See, I kind of like to do 2 more of these.
Oh, don't you- I feel like I know
At
what's
least
on.
1, possibly 2.
We need homework time, remember?
I can start with one.
I'll take care of you. Don't worry. Don't worry. I got you.
There's gonna be one question to that show.
No.
Oh my god.
Okay. So, how much water should be added to 20 liters of an 18% acid solution to reduce the concentration to 15% acid? All right, so same general idea. My labels are going to be the same. We're talking about these concentrations, so it's just amount times concentration equals the amount pure. Right, my labels, you can be as specific as you want. If you want to keep it very generic, you can do first, second, and total. All right, so when I look at this, it starts out, how much water? So that would be my X. Okay, concentration. I didn't say the concentration of that.
0.
Okay, if you go get a drink out of the water fountain, what percent acid is that?
Should be.
Should be none, right? Pure is 100% acid, but if it's water, that's 0%.
Well, that gets rid of our X.
So in the second one, we want to add 20 liters of an 18%. So my amount is 20. My concentration, 0.18. To reduce the concentration to 15%. So my total concentration is 15. What would I put here?
X was 20.
All right, so I wanted to do this one specifically because of the fact that you were mixing water. And no matter what you're looking at, if you're talking about water, your concentration is 0. So when I multiply 0 times X is 0. And I have my 0.18 times 20 and my 0.15 times X plus 20. If you can get to this final column, you have your equation. You add the first 2 to equal the total. So 0.18 times 20, 3.6 equals 0.15x plus 0.15 times 20 is 3. Subtract over your 3. Divide by 0.15 and we get x to equal 4. And the question was just how much water. We were in liters.
So anytime we have water, make certain of the substance, we make the concentration 0 for the.
Yes.
What? If it specifies the water
Only
is
time.
at 0 for whatever reason?
Then it wouldn't be water.
Okay.
So water is always a concentration of 0. Okay, I want to put one final problem. Last example of the day. This is one that I actually stole off the food science contest.
It's the.
This thing be sliding, bro.
It's the what?
Okay, so
It's the.
you have 30% cream
There's 4
and 3.5% milk. So we are mixing together first, second total, or if you want to call it cream, milk in the total, whatever. But if you just look at these percents, you know that 7% has to be the concentration of the total because it falls in between the other two.
Yeah.
7% is 0.07. So these have to be my 30%, which is 0.3, and 3.5%, which is 0.035. Okay. You want to make an 8-pound batch. What's the 8 go for? The total amount. So that's what's different on this one. Do I know how much cream?
Yeah. So X
So that's
8.
X, but 8 is my total. So let's say if I put in 2 pounds of this and my total was 8, how much would I have to put in for the second one?
4. So
It has to be
8
8
minus
because 8.
X.
X equals 8.
If I put in 2 of the first and my total has to be 8, then to get the second one you would have to subtract. This would have to be your 8
Hold
minus X because
Minus X.
8 is my total this time. That's what changed.
I don't know.
Alright, then you solve it the same way. You multiply the rows. And we add the first 2 to equal the total.
Who's ordered? What? So look at 2.
Alright, so 0.035 times 0.28 minus 0.035x equals 0.56. Add like terms. And I'm going to subtract over my 0.28. And so then final step, you divide those things and what do you get?
So I'm guessing you can't get a negative?
You cannot get a negative.
Point
Yeah.
one.
That was
1.056603774.
Well, I had to subtract.
You didn't distribute.
I do.
That's a big number.
Comma all that.
Yeah, I don't know if that's the right answer.
Yeah, I feel right.
I don't know if that's the right answer. I ain't gonna lie. It's pretty big number.
Yeah, this one doesn't work out perfectly. Let's round to 2 decimal places.
So would it be 1.0?
I got 1.5.
Second one, 95.
I got 1.0.
Well, when you round up,
When you round up, you round up.
You got round up. I just have pure just 1.05.
Boom.
I got 1.05 too.
I got 1.05660.
Well, you just round up.
Wait, is this the right one? Is this like the right one?
Oh, it
Yeah, okay, I did it right.
That's your stick there.
This number.
It's 1.06.
Yeah.
You dropped an
Yes,
X
right
there.
When you distributed that.
That's what I'm saying.
So I told him before.
Okay, so then final answer, what do you have to do?
Oh, right, sentence.
Write a sentence. So you would just say the batch needs 1.06 pounds of cream in it.
Third hour of the elementary plan. Mrs. Calvin, son's sick. She's got 6 days come over. Okay, so, okay, thank you.
You're welcome. Okay, so for homework, that handout from yesterday, I want you to do 3 problems.